Hello class, we're about to start Chapter 6, Factoring Polynomials. Section 6.1, the greatest common factor and factoring by grouping. Objective 1, find the greatest common factor. Recall that the greatest common factor, GCF, of a list of integers is the largest common factor of those integers. Now, we're given these values, 24 and 30. Now this is how we break up the factors. For 24, your lowest factor is always 1, and your highest factor is always the number itself. And the factors, remember, factors are numbers that are multiplied. So when you multiply the two factors, it should give you the number you started with. So we have 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. These are all the factors of 24. Now 30. All these commas had disappeared here. Let me put our commas in here. We have 1 times 30, which is 30. 2 times 15 is 30. 3 times 10 is 30. And 5 times 6 is also 30. Now that we have done all of the factors for these two numbers, we pick the number that's the highest that both of them have in common, which happens to be 6 here. So 6 is the greatest common factor. 6 is the greatest number they have in common. Now, we go down here to the next set. Now, we have three terms here. We have 27, 45, and 72. So we have the factors of 27, which is 1, 3, 9, and 27. 45, we have 1, 3, 5, 9, 15, and 45. And 72, we have 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. And remember, when you match these numbers up, they multiply together to give you the number you started with. Now, if we look here, we have to pick out the greatest common factor. The greatest common factor of all three of these is 9. So your GCF is 9. Now we go here to 30 and 75. Now we have the factors of 30 and the factors of 75. Now if we notice here, the greatest common factor of these two terms is 15. Now we go here to 12, 15, and 20. Now we have all of their factors, and it looks as though the greatest common factor that 12, 15, and 20 has is only 1. They only have 1 in common. Okay, now, the next thing, we have 9a to the 5th and 15a. Now, I want you to pay close attention to this. Now, first of all, we're not going to deal with the variables initially. We're just going to deal with the numbers. The greatest common factor of 9 and 15 is 3. Okay, so we have 3. Now, this is what we do with the variables. We look at the variables. We have a to the 5th and a. If both of them have the same variable, their greatest common factor is the variable with the lowest exponent. Again, their greatest common factor is the variable with the lowest exponent, and it happens to be a here. So the greatest common factor of 9a to the 5th and 15a is 3a. Now we come down here. The greatest common factor of 8 and 24, we notice their greatest common factor is 8. Now the variable x to the 7th and x to the 5th, we take the variable with the lowest exponent. So your answer is 8x to the 5th power. Now we have these three digits here. The greatest common factor of these three numbers here is 1. That's the only thing they have in common, is 1. Now we look here at their variables. The variable with the lowest exponent here, all of them have n, and the variable with the lowest exponent is n to the 4th power. Now 1n to the 4th power, we should write that as just n to the 4th power. And that is our greatest common factor. Now we come down here. Now of course, I expanded my boxes here so that I could show it to you, better. So my pages are a little bit more expanded than yours. So now we come here to our greatest common factor of 12, 18, and 15. Now, if we look here, the greatest common factor they have here is 3. So 3 is your numerical greatest common factor. Now we look here, all of them have a W, all of them have a Z. The W with the lowest exponent is just W itself. Now with our Z's, the lowest exponent is Z to the second power. So our greatest common factor is 3WZ to the second power. Okay, class, it says the GCF of a list of monomials is the largest term that is a factor of all terms in the polynomial. How does this work in practice? Okay, now, what we're going to do this. We're going to write this 4Z squared and also, let's say 8Z to the fifth power. Now we're going to compare these two terms as our examples here. So we would take 4 and 8. 4 factors are 1, 2, and 4. Now this is very, well, let me go back down here to 8 first. It'll be 1, 2, 4, and 8. Now one thing I didn't do up here, which I have to explain, is when we come to a problem like, which one was it? Like 9 here. I didn't explain the factors of 9. If you notice, we have 1, 3, and 9. Remember, 1 times 9 is 9, but we know 3 times 3 is 9. Whenever you have a number multiplied by itself as a factor, you only write it one time. Now, when we come down here to the example that I just gave you all, we have 4. Now, we know 2 times 2 is 4, but we only write the 2 once. So we have 1, 2, and 4, 1, 2, 4, and 8. Now, with our coefficients here, what we would do is find the greatest common factor of both of those, which happens to be 2. So that is 2. Now we come here to our variables. Now our variables are Z squared and Z to the fifth. Now we know we take, since they both have the same variable, we take the variable that has the lowest exponent. So that would be Z squared. So our greatest common factor of these examples is the coefficient, which is 2, and the variable with the lowest exponent. So it'll be 2Z squared. Now we have objective 2. It says factor out the greatest common factor of a polynomial. It said method for factoring a GCF out of a polynomial. First, we find the GCF of all the terms and write it down. Second, we write down what is left of the polynomial once you factor, divide out the greatest common factor. Now we look here. Remember, we have our terms. Our terms are separated by addition or subtraction. So we have one term of 5x and one term of 10. Okay, now, just so we could show you an example here, and I'm not going to do this for every problem, we can imagine that we're trying to find the greatest common factor of 5x and also 10. Now the factors of 5 is 1 and 5. The factors of 10 is 1, 2, 5, and also 10. Now their greatest common factor is 5 here. So we'll write down that 5. Now if you notice, both of these terms do not have x, so we do not write x here. So what we factored out here was 5. But since this is an expression, we have to put this, what's remaining, inside of a parenthesis. Now to determine what goes inside this parenthesis, this is what you would do. And I'm going to write this off to the side. You would take those terms and you would divide those terms by what you factored out. You factored out a 5. So you divide both of these terms by this 5. So we know these 5s will simplify out and leave you x. This 10 divided by 5 is positive 2. And you write it with its sign. And that is it. So we just factored A. Now, let's go over here to B. We have 125, x squared, and 20x. So we could go over off to the side here. We have 125, and we also have 20. we don't need to write the sign as of yet. So it'll be 1 and 125. And then we know 5 times 25 is 125. And these are the factors of 125. Now 20 we did earlier. It was 1, 2, 4, 5, and also 10 and 20. Now, the greatest common factor they have here is 5. Okay, so we know we will factor out a 5. Now, we look here at these variables. We had x squared and x. Both of them has an x, so we take the x with the lowest exponent, which would just be x. Now, in this parenthesis, we would take this 125 x squared and divide it by 5x minus 20x over 5x. Remember, we divide each term by what we fact our greatest common factor. 125 divided by 5 is 25. X squared divided by x, we know we have the same base. We subtract the exponents. 2 minus 1 is 1, so it'll just be x. Now this is minus 20 divided by 5 is 4. And we know these x's simplify out to 1. And 4 times 1 is 4. So our final answer is 5x times the parenthesis of 25x minus 4. Now we go down here to C. Now with C, we have 15w cubed and also 12w squared. We can go off to the side here. The factors of 15 is 1, 3, 5. Oh, for some reason that disappeared. So again, it's 1, 3, 5, and also 15. Next, we have the factors of 12. 12 factors are 1, 2, 3, 4, 6, and also 12. Now, their greatest common factor is 3 here. So we know on the outside here, we will have 3 and then our parenthesis. Now we know, well, one thing we forgot here that I had forgot was that we're supposed to do that w. So let me make a little bit of a correction here. So we had w cubed and w squared. So it'll be 3w squared, because remember, we always take the lowest of the variables, the variable with the lowest exponents. So we had 3w squared. Now that is on the outside. Now on the inside, we could take 15w cubed divided by 3w squared plus 12w squared divided by 3w squared. 15 divided by 3 is 5. W cubed divided by w squared, we know we subtract the exponents. 3 minus 2 is 1, and we'll be left with w to the first power, or just w. Next, 12 divided by 3 is positive 4, and the w squared simplify out. So our final answer here would be 3w squared times the parenthesis of 5w plus 4. Now we come here to D. We have the factors of 100, 50, and 100. Now, we don't have to do 100 twice. Once we do one of those hundreds, that account for the other 100. So we'll just do 150. Now, hopefully I have enough room here. It's 1, 2, 4, 5, 10, 20, 25, 50, and also 100. Okay, now with 50, we have 1, 2, 5, 10, 25, and 50. So we know our greatest common factor here is 50. Okay, so now we have 50 on the outside, and we look here at our variables. All of them have a y, and the lowest y we have is y squared. Now we will put the rest of these terms inside the parenthesis. So we'll divide all these terms by 50y squared, which we will write off here to the side.